In this video, we're going to evaluate the integral from 0 to pi with sine squared of x dx. And you may be thinking, well, I can't really find something's derivative that equals sine squared of x. I'm going to put sine squared of x in a different form. And you might be thinking that you could use the identity cosine squared plus sine squared equals 1. That doesn't really help, because then you still have to evaluate cosine squared of x, and that's no easier than sine squared of x. However, you could use the half angle formula. And we have sine of squared of x is equal to 1 minus cosine of 2x over 2. The 1 for cosine is just a plus over here, pretty simple to remember. Ignore the noise in the background. So now we can rewrite this integral as 1/2 of 1 minus cosine of 2x dx. And we haven't done any substitution or anything, so this doesn't change. We're still in terms of x. We've just wrote sine of x in a different way. So now I can think over here. Something's integral equals 1, and then something's derivative is cosine of 2x. So this is a pretty simple one. If something prime equals 1, that means that it itself was x. And then minus cosine of 2x. So sine of 2x equals, or sine of x's derivative is cosine of x. Sine of 2x is derivative is cosine of 2x, but then you have to use a chain rule times 2. So I'm going to multiply by 1/2 sine of 2x dx, and I should not have written this. At this point, we've already done the integral, so we can get rid of all those stuff. This is just from 0 to pi. And now I'm going to evaluate that, and it's going to be 1. Again, we're replacing x with pi over here, so it's going to be pi minus 1/2 cosine of 2 pi minus 1/2 of 0 minus 1/2 sine of 0. So this right here, this is pi over 2. Sine of 2 pi is 0, so that second half becomes 0. Sine of 0, 0, 0, 0. So it's just pi over 2 minus 0, which is the same thing as pi over 2. That right there is your answer. Thank you much for watching, and goodbye.